So in the last class we have discussed about some of the terminology related to probability, okay? Like sample space, event, simple event, compound event, up and like outcomes and sample point and many things. These are the some terminology related to probability, okay? So we have almost covered everything related to terminology and different like the meaning of and or A or B, A and B, A not B, like A minus B, A union B, A intersection B. So all those things we have discussed. So today we'll solve some numerical because there is a lot of theory in probability. If we solve some numerical, then you will have a better feel of it. Okay. So let us try to in the previous session we have not tried to find the probability. Okay. So today we will try to find do some numericals and find out what is the probability. Okay. So let us say let us say there is we have done an experiment. Okay. So uh, we have pulled three samples out of a total there are so many items or the products. Okay, that is being manufactured, and you have pulled just three out of it. Okay, maybe there in a bag, in a bag of so many items, you have just pulled three out of it. Okay, so when you are pulling three out of it, like in context of manufacturing, there a part there will be thousands of parts. Okay, so you cannot check all of them. You sometimes you do the sampling and like say there are thousands, you are just pulling 5, 10 out of them and you are doing the checking. So in this case, uh, you are pulling out three items. Okay, three items or three parts. Okay, so what will be the sample space? Okay, so so the sample space related to that experiment is S is equal to B B B B. Okay, it means bad bad bad. Okay, then B B G. Okay, then B G B. Okay,
Okay.
that is one combination of like B B B B B B and like. Okay, so how it is, like say you start with B. This is one, and then G B B G B B B G G B G G and G B G. Okay, so this, and then G B G G B G G G B G G B G G G. Okay, so you have done an experiment, and let us say this is your sample space. Okay,
Okay.
so uh, so this is like this. Let's say with the sample space associated with an experiment examining three consecutive pens produced by a machine classified as good or non-defective and bad defective. we may get one, two, or three defective threads as the result of the examination. Okay. So, so when you are pulling three pens, okay, so it can be like first can be G, okay, then second can be either good or bad, right?
Okay.
Right, this. Then third can be either good or bad.
Yes.
Okay. Then uh, fourth can be either good or bad.
Yes.
Okay. So this is one combination. Then other one like so this is uh, so how many you are getting by this? So you are getting GBG, okay, GBB, okay, then GGG and GGB, okay. So this is one combination you are getting. Or first can be bad also, right? First can be bad,
Yeah.
okay. Then the second can be uh, uh, good or bad.
Bad.
Okay. Then again good or bad. Okay.
Yes.
Then good or bad.
Bad.
Okay. So this, if you analyze, it will be BGG, BGB, BBG, BBB.
B.
So this is what we have got, 8.
Yeah.
Okay, you can see this can be the so this is the total sample space.
Yes.
So 8. Okay. So so each of them are sample point. Okay. So this is a sample point, this is a sample point, and
Yes.
all. Okay. So sample point. So the probability of the sample point. So probability of sample point. Say probability of sample point is your will be 1 by 8, right? 1 by 8, because there are
8 sample points.
there are 8 sample point. So probability of each sample point is
1
1 by 8. Okay. So let us say let event A there is exactly one defective pen. Okay. So we want to find the probability of exactly one defective pen.
Okay.
So where exactly one defective, B stands for bad.
Bad. Defective.
Okay. So where we have only single B, that is one defective, exactly one defective. Okay. So this is one. Okay.
4 by 8.
This is one. Right.
The next one also.
This is also one. Okay.
The next one. Here. GB.
This is also. Anywhere one, only one B.
That's
Okay.
it.
These 4. Okay. So exactly one defective. Okay. Okay. That even there is exactly one defective pen, and even there are BG, GBG, GGB.
There it is only 3 by 8.
Where?
In this column where you've written 4, 4, you'd like each.
Oh, I think I have written one extra. 4,
Yeah.
6, 3, 9. I think I have written one extra there.
That GBG you've written twice.
BBVG,
GBG twice.
Oh, okay. Which one written
GBG, GBG, last one.
twice? Last one.
That
It
is
is
a-
twice. I have written. No? GBG already
Next
there?
also is GBG.
Okay, okay. So there is a mistake there. So this is the correct actually. Based on this, you will arrive at that. So we have got 1, 2, and 3. Okay. So the question is probability of the event where you have exactly one defective.
Yes.
Okay. So what is that event? That event is BGG BBG and ZGB.
Yes.
So that event, this is one, this is one, this is one. So there are three occurrences. So the probability of that event becomes, this is how we find probability. The probability of that event becomes uh, like probability of this item, probability of this sample point, this sample point, this sample point. So probability of each sample point, addition of probability of each sample point. So it will be like 1 by 8 plus 1 by 8 plus 1 by 8, which is equal to 3 by 8. Clear? Okay. So you can take a picture of it. This is how we get the probability. Okay. And there can be an event. There can be one event B, like there are at least two defective pens. Okay. Okay. Just 1 second. One more event we can say. Another event B is at least two defective pen. Defective pen. Okay. At least two defective pens. So where you are having at least means what? It can be 1 or it can be 2.
Yes.
Right? So or it can be 0 also. Right? At least 2 means what?
Yeah.
At
0
least
also. At the most 2 is that.
At the most 2
Will
is
include 0.
include 0. At least
No.
At least means it will be either 2 or 3.
3.
Right? At least 2 means you will have minimum 2 or 3.
Starting is
3.
2.
So 2 or 3 means 2 or 3 bats.
2 up to the maximum common
So which are the 2 bats? This is 2 bat. This is 2 bat. This is 2 bat. Okay, and this is also 3 bat. Right? Right? So so we are finding it like it is BBG GBG is not 2 bat. Okay. So BBG, BGB, GBB and BBB. So this is the event B. Right?
Yes.
So here also probability of B is 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8 is equal to 4 by 8. Clear?
Yes.
So now it. Okay. So now we'll do one more numerical. So if you do more and more numerical, you will have better understanding. Okay. So after solving this, if you do conditional probability, then Bayes theorem is related to conditional probability. Okay. Then the binomial, this thing.
Bernoulli's trials.
Bernoulli's
Trials.
Bernoulli's trial. Okay. So for Bernoulli's trial, you need to understand binomial, binomial theorem. Okay. Binomial theorem and probability distribution. So those things, once you understand the basics, those things will be easier for you. Okay. So now we have solved. Let us solve one more example. So what we have solved is you have just pulled three items. Okay, you have just pulled three items and good, bad, and you find out the probability of at least two bad or at most two bad or good. Any there can be a number of numericals found out of it. Okay, okay. So let us consider another experience of tossing a coin twice. Okay.
Okay.
So when you toss a coin twice, what will be the sample space? So I'll get first head, then tail. Okay. Then it will be like this. So you let us do it in a more formal way. First one is head, second one can be head or tail. Okay. First one can be tail, second one can be head or tail. Okay. Right?
Yes.
So, hmm. The here the outcome will be HHHT. Okay. Here the outcome is
THTT.
THTT. Okay. Okay. So, these. The sample space of the experiment is anyway this. So, let's say probability of two head will be equal to 1 by 4, right? Probability of two heads will be equal to 1 by 4. Okay, so then let us go into another numerical probability of equally likely event. Okay, so let a sample space experiment be. So let a sample space experiment be equal to W1, W2, W3 or whatever. Okay, let it be like this till Wn. Okay. Hmm? So let all the outcomes are equally likely to occur. Okay. So the chances of occurrence of sample equally like means each sample event must be same. Okay. So so probability of W1. Okay. Probability of W1 is equal to P and W1 is a subset of S where 0 less than equal to P less than equal to 1. Probability can never be greater than 1. Okay. And so sum of n is equal to 1 to n. Okay. Sum of n is equal to 1 to n. Probability of W, let us say I, okay, is equal to 1. It will always be equal to 1. Right?
Yes.
So, is probability of here
Maximum.
basically it is the sum of probability of each
Each
sample
sample
point
space.
will be equal to 1. Okay. then so this is one total probability of all the sample point is equal to 1. So these are called equally likely events or whatever, okay. So probability of event A or B, okay. So we have a event A, we have a event B, okay. So probability of event A or B is equal to probability of A union B. Or means union, okay. That we know, okay. So so you might have studied in your set theory, probability of A union B is nothing but probability of A union B is nothing but probability of A plus probability of B minus probability of A intersection B. Because you cannot add things twice. So you let us say this is your the complete stuff, okay, and let us say you have A and let us say you have B, right? This is your A, this is your B, okay. So this part, like say, let me mark it. So this part, okay, this part, this is one part, this is your another part, okay, which is not taking the intersection into consideration, okay. So this red part is nothing but your A minus B. This red part is nothing but your A minus B, right?
Yes.
And this green part is nothing but your B minus A, right? B minus A. And the total thing is A. Total circle is A. So your total circle is A. A. And here the total circle is B. So we have told that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Why it is? Because when you are adding two things, these things where you have an intersection, that is getting added twice. So to avoid double accounting, you are just removing it. Okay. So that is what the probability of A union B. Okay. And if the A and B are called, if A and B are disjoint sets, if there is nothing common between A and B, if there is nothing common, so what will happen? Suppose this is A and this is B. There is nothing common. There is nothing common. Okay. Intersection is almost zero. So in case of disjoint sets, probability of A union B equal to probability of A plus probability of B, because probability of A intersection B is null, right? No.
There is nothing common.
Nothing common, okay. So similarly, for that is also called mutually exclusive.
Yeah.
So if A and B are mutually exclusive, then P and intersection B is equal to null. Okay. Okay. And then so we have discussed about OR now. OR. So this is OR. What we have studied is OR. Okay.
Union.
Union. Okay. Then there is something called AND. Okay. So A and B. So A and B is nothing but this term, A intersection B. So AND is nothing but probability of A intersection B. That is this part, this intersection part. That is
The
your
common part.
common part. Okay. So take a picture. We'll do some numerical. Okay. So we'll related to this. We'll do some numericals. So these are all there in class 11. So in your JE or JE, these things will come. This understanding it may not be there in class 12 immediately, but to do Bayes theorem, conditional probability, understanding of this like finding probability, knowing what is intersection, what is union, all these things are quite essential. Okay. That's why we are starting from the class 11 steps. Right. Okay, let us do one numerical. Okay. Consider the event A. Okay. Consider a event A associated with experiment of drawing a card from a deck of 10 cards. Okay. 10 cards numbered from 1 to 10. Okay. So numbered from 1 to 10. So you have 10 cards. 10 cards. The sample space will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10.
Okay. So you will draw one card. So consider event associated with drawing a card from a deck of 10 cards. So so you have in a event you have a event can be, let us say there is a event 2, 4, 6, 8. Okay. So this can be event. So combination of sample point is a event. Okay. So this let us so in all the outcomes 1 to 2 are considered equally likely. So these are all are equally likely.
Yes.
It can be anything. Okay. So then the probability of each outcome is 1 by 10.
Yeah.
So probability of 2 is 1 by 10 because these are all equally likely. 1 by 10, 1 by 10, 1 by 10. Okay. So the probability of event A is equal to 4 by 10.
Yeah.
Right? So
2 by 10.
probability of this event is 4 by 10. Okay. So what we have done here is 2, 4, 6, 8. Okay. So there is something called probability of A naught, A dash. Okay. So A dash is called not A. A dash is called not A. So not A is what?
Total
1,
sample space minus
1,
4 by 10.
1, 3, 5, 7,
The total
9,
thing
10.
minus 4 by 10.
So these are not A.
Yeah.
So probability of not A is equal to 6 by 10. Right?
1 minus 4 by 10.
So probability of not A is equal to 1 minus probability of A.
8.
That is one inference. Okay. Probability of not A is equal to this. Okay. Okay. So, okay, so uh, let us try to do one more numerical. So, probability of not A is equal to 1 minus probability of A. So, probability of A plus probability of not A is equal to 1.
Yes.
So, you can infer that probability of not A and probability of A are mutually exclusive, right?
Yes.
There is nothing common between them, right?
Yes.
That's why they are mutually exclusive. Okay. So let us do where the concept of combination can also be used. One numerical where the concept of combination can be used. Okay. So the question is, a committee of 2 persons is selected from 2 men and 2 women. Okay. So we have 2 men and 2 women. Okay. We have 2 men, 2 women. Okay. 2 men and 2 women. We are forming a committee of 2 persons. Okay. Committee of 2 persons. Okay. Committee of 2 persons. Okay. Committee of 2 persons selected of 2 women. What is the probability of a committee which has no man? Okay. The question is probability of a committee having no man. What is the probability? That is the question. Okay. So the answer will be no man in the committee of 2 men. There will be 2 women in the committee. So no man in the committee of 2 means there will be no woman. 2 means there will be 2 women in the committee. Okay. So no man means what? There will be 2 women in the committee. So what is
Committee
the
is two
probability?
people.
Committee is 2 people. So what is the probability of having exactly 2 women
women.
in the committee? Okay. So 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 first we have to find out the sample space. Okay. So here we have how many people?
4.
4. Okay. We have to select 2. Okay. So what is the sample space? That is
2 women, 2 men.
there comes the concept of combination, not permutation. Just remember, it's combination. See, permutation is repetition. See, you, me, you
Is permutation.
is a permutation, but only you, me is combination. Means you, me, you are same in terms of combination. But you, me, you are different in terms of permutation.
Yeah.
So that's why
order matters.
So that's why order matters in case of permutation. Order does not matter in terms of combination. Okay, so what will be the sample space? So you are forming a committee of 2 people out of 4 people. So what will be the sample space? It will be 4C2. Right? This will be in these many ways you can do it. So that is the 4C2. Okay, that will be the one. And then what is this question now? Probability of a committee having no man. That means probability
exactly
of having 2 women. Okay. So there will be 2 women in the committee. Okay. So out of 2, so you have only 2 women. Okay. So you have only 2 women and you want to select 2 women. So how many ways you can do it? 2C2. Right. So,
Yes, yes.
so this is the sample space. This is all possible ways.
That is the one we want. 2C2.
All possible ways. Okay. This is the number of ways of selecting two women. Clear? So the question is forming a committee without man. There won't be any man. That means you have to select from two women only.
Yeah.
Okay. So there are from two women you are selecting, and you want two women also. Having no man means two women. So what will be the probability? So probability of no man is equal to 2C2 by 4C2. Okay. So you know this is 2C2 factorial by 2 factorial 0 factorial, then 4 factorial by 2 factorial n minus r factorial, right?
Yes.
So NCR is equal to n factorial by r factorial into n minus r factorial. So that's what. So it will be 2C2 is nothing but your 1. This one will be 4 into 3 divided by 2 into 2, right?
Yeah.
So this become
4 into 3 into 2.
right. Sorry. Yeah. So this become 2 cancels out, 2 6 1 by 6. That's the answer. Okay. So like this, let us say there is probability of having let us say then the next question is probability of having one man in the committee. Okay. So
1C.
so
One
one man in the committee means that there is one woman, right?
Oh, yes.
Okay, so one man in the committee means there is one woman
One
also.
man.
Okay, so you are selecting one man out of two can be. Okay, so here comes the multiplication.
Yeah.
Okay, so you want
One man out
probability
of two men.
probability of having one man.
Yeah.
Okay, so probability of having one man means one woman also, right? Clear?
Yes, because
So,
there are two people.
probability of having one man is nothing but like 2C1, right? 2C1, right?
Yeah.
2C1. Similarly, 2C1, one woman also.
Yeah.
So out of two you are selecting one.
NC.
Out of two you are selecting
One.
one. So this will here comes the multiplication. Because what I am doing, I am branching out.
Yeah.
I am branching out.
Understood.
So branching out is nothing but your multiplication.
Multiplication.
Okay. So 2C1 you are multiplying. Okay. So so probability of event having one man and one woman is nothing but your probability of so it will be 2C1 into 2C1, and then you know the sample space is always like when you are selecting 2 out of 4, it will be 4C2, right? So the first term is the sample space, the total everything that is possible. Okay. So this becomes 2C1 is nothing but 2 factorial by 1 factorial or whatever, 2 minus 1, right? Into 2 1 factorial. So this is 2 into 1.
4 by 6 you get.
2 into 1. Then this is 4, 3, 2. So
By
4C2 we have already found out.
6.
6. Okay. 6.
4 by 6.
So it becomes 1, so 4 by 6.
2 by 3.
2 by 3. So this is the answer. Okay. Probability of committee having a woman. Woman means so there comes the multiplication. You have to be very careful there because you are branching out. Okay.
Yeah.
Okay. So it is in a four way it is happening. Okay.
Yeah.
Okay. So having two women, one man, one woman. Okay.
Understood.
Out of four. When you are selecting out of four, one man, one woman can happen in four
Four
ways.
ways.
Okay. Out of four, when you are selecting one man and one woman, it can happen in four
Four
ways. And out of four, where there are two men and two women, one man and one woman can happen in this way. This is very important concept.
One woman
Hmm.
means there should be one man because committee
Huh.
has
So
two people.
when you are selecting one, 2C1, 2C1 that
One
has to
out
be
of two
multiplied.
people.
So that has to be multiplied. This
Yeah,
is
yeah.
very important here. You should remember that.
Yeah.
Okay. That is the catch. So this multiplication, and then you know 4C2 is the sample space.
Yeah.
So now you understand how to solve different numericals on probability. So these are all the theory behind it. Now using this theory you can solve n number of numericals. Okay. And okay, so you can do n number of numericals using this. Take a picture of this. We will solve one more numerical. The probability is very interesting stuff. If you understand, it is very interesting. Okay, so it is like if you understand a little bit of theory behind it, there can be any number of numericals formed, and if you solve more and more, you will have more and more understanding of it. Okay, if you solve more and more numericals, you will develop more and more understanding of it. So this cards, playing cards. So there are lot of problems on probability can be found related to playing cards. Okay, so we'll solve one related to this uh, playing cards. So, okay, so the question is find the probability that when a hand of 7 cards is drawn from a well shuffled deck of 52 cards. So you have 52 cards, right? 1 to 13, 4 like you have the heart, you have the diamond, and you have the spade, and what is the other one?
Clubs.
Clubs. Okay. So you have clubs, you have club, you have diamond, and you have
Heart.
heart,
Spade.
spade. So you have a club, so that is
Black.
okay. So this you have the diamond. Okay, you have the diamond. You have the heart, and you have the spade. How does the spade look like? I'm forgetting.
Panapatra.
Mm. Something like this. And this is the spade. So you have 13. So in our childhood we used to play a lot of cards. I am forgetting. 13. Okay. 13 cards. Okay. And total number of cards. Okay. 7 cards. So in this case there are 15 cards. You are drawing 7 cards. 7 cards you are drawing. When you are drawing 7 cards from a deck of 52 cards, what is the probability that it will contain all kings? Okay. Probability that all 7 are kings. So you know beyond 10, this 11, 11.
One is king,
Ah.
one is queen, one is
So
ace.
11, 12 and 13. So this 12 is your queen, what I remember, right?
Yeah.
13 is your king.
11 is ace.
This is the S, highest value. Okay. So this is the S. So it contains all kings.
There
Okay.
are 4 kings.
So in the card there will be a maximum 4 kings.
Yeah.
Okay.
Totally a wheel.
So what will be the probability of this? Okay. So so the first numerator will be probability that all hands will be 4 kings. Okay. So there are
7.
so there
4
are
by
hmm,
50.
so probability a hand will have all 4 kings. So what will be the sample space first?
52.
So you are drawing 52 out of
7
you
out
are
of
drawing 7 out of 52. So
4
this
by
is going to be in the denominator. Then there is no doubt about it. Now probability of all 7 are kings. So there are only 4 kings.
So 4 out
Okay.
of all.
So there are, that means probability of 4 kings and the rest 3 are something else.
Yeah.
Okay. So 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 this probability will be like you 4 there are only 4 kings. You can draw 4 kings out of 4 in 4C4 ways.
Yeah.
Right? So for drawing kings, what is available for you? Only 4 kings.
Yeah.
Right? For drawing 4 kings, available for you is only 4 kings.
Yeah.
So that is one way. And then other 3 you have to draw
From seven.
out of 48.
Yeah.
48 C3. Right?
Totally 7.
So total 7. So these 3 added together is 7. These 3 added together is 52. Okay, so there is one way, there is these many ways you can draw 4 kings. There is only one way actually. Okay,
Yeah.
with 4 factorial by 4 minus 4 factorial
Because
divided
I'm
by 4
selecting
factorial.
all 4.
Only one way. You can select all 4 kings. Okay. So that 4C4. But when you are selecting 4 kings, there will be 3 other cards also will be drawing from 48
Other cards.
48
Because you
cards.
selected first 4.
So this answer to it will be 4C4 into 48C3 divided by 52C7. Okay, this is the probability of drawing all 4 kings. So never ever forget this multiplication. See, you just say that okay, what is the way of selecting 4 kings,
But
and
there are-
then you just put 4C4 and
But you have
52C7.
to
That
select
is wrong.
7 here.
You are selecting 7.
There are
So
3
the
more.
other 3 in how many ways where you can select.
Understood.
So this is going to be a big number actually.
Yeah.
48C3 is going to be a big number.
Yeah.
So that you should not forget. Okay. And what is the probability of drawing 3 kings? Okay. What is the probability of drawing 3 kings? Okay. Okay. Probability of at least 3 kings. Okay. So probability of 3 kings or 4 kings. So this is the probability of 4 kings, right?
Yeah.
This is probability of 4 kings.
At least means 3 and 4.
Probability of 4 kings we have got now. Okay. All 4 kings. Okay. Then there is another question. Probability of minimum 3 kings. Okay. So it can be probability of 3 kings or 4 kings. So probability of 3 kings is probability of 3 kings will be 4C3, right? And into 48C4. That remains the same.
Yes.
This here for C3, this is 4.
Yes.
This should total should be 7.
Yeah.
Okay, you are drawing 7 cards. So this is the probability of 3 kings. Okay, and the sample size remains the same.
52 C.
So this term plus this term 4C4 into 48 C3 divided by 52 C7. So this is probability of at least 3 kings.
Yeah.
This is you are adding on extra term here. You have to
Understood.
find the probability and then denominator will remain same. So that is how we have solved a numerical related to cards. It can come because there will be lot of numericals related to cards. Okay, so this we have completed almost the 11th probability everything. Now having a foundation on probability, we can easily do the conditional probability, Bayes theorem,
Bernoulli's
Bernoulli's
trials.
Bernoulli's
And
trial,
frequency distribution.
and frequency distribution. So what remains for us is conditional probability. Once you understand conditional probability, then Bayes theorem, and then Bernoulli's trial, and then probability distribution. So in the next class, we'll finish all or one or two class. In another 1 hour or so, we'll finish all of them. Okay, you can take a picture. Okay, fine. We'll take.